In this video, we're going to talk about the current and the drift velocity, on how these two quantities are related to each other in an equation. And you need to know how to derive this equation. So let's start the derivation. First of all, we have the equation of Q equals to IT, and we also know that total charge is equals to number of electron times the charge of one electron. So now we are going to put these two together. It become IT equals to NVE. So why is it NVE? Is because the small n here indicated number of charge per unit volume. So when it's multiplied by the V here, we basically get the total number of charge. So this is the volume, and this is number of charge per unit volume. Okay, so N over V times V, you get back capital N basically, so the number of electrons. Okay, so next line, we have the T move over to the other side. Okay, we have the T move over to the other side is divided by T, and we have the volume expanded into A and L. A is the cross-sectional area of the conductor, and L is the length of the conductor. So what we get here is we have L over T. I just group these two together. So L over T. L over T basically is the velocity, the drift velocity. Therefore, at the end we have NAVE. Current equals to NAVE. So where the V is the drift velocity. Okay, so that's how it is derived, and current related to drift velocity by NAVE, where this N here is the number per unit volume. Let's look at one example of the calculation here. Find the steady current in the circuit when charge is 40 coulomb, passes in 5 seconds. So we have from I equals to Q over T, we have 40 coulomb divided by 5 seconds, so that's 8 ampere. So second question, we have this amount of electron pass through in 60 seconds. Calculate the charge which passes the point in 60 seconds and electric current. So from Q equals to NE, you can use a capital N here, yeah, to indicate that that's number, not number per unit volume. So capital N, so we have 1 times 10 to the power 20, that's the number of electrons, times the charge of 1 electron. The negative, you can just take it out in the calculation. So the total charge will be 16 coulomb. Okay, total charge is 16 coulomb, and current is charge divided by time times 60. You put that into the equation, you get 0.27 ampere. Okay, so next question, we have calculation of drift velocity. We are given the A here, that's the A, we have the current I, and we have the N here. Okay, so to calculate that, we have I equals to NAVE or NAVQ. This is also in E if it's electron. So we have 2.5 as the current, and the N, the A, and also the charge of electron. So from there you can get the V as 1.8 10 to the power negative 4. Alright, then the next question, we have this. That will be your assignment question. Okay, I will give you the answer first. Alright,